Give it a minute. Okay, welcome to episode 18 of a little live stream where I write a small interpreter in C++. I imagine we're up to 20 odd hours. I don't do all the coding on the stream, sometimes I do some other bits, but I would say 80-90% of the code is done live streaming. The time is, it's a bit earlier today, 9:14 UK time. And I'm not quite sure, I'm trying to recall where we left off last time. We were hunting down a bug in our factorial code. It was previously returning 60, and now we got it returning 2. So the problem was that the factorial was working fine, except for the case where we went from 2 to 1. The number was going to 1 rather than 2. We reduced our factorial 5 function down to just a factorial 2, and that I think was where we left it. We were about to start debugging into the program, looking at the bytecode, which is my made-up assembly language for this stack-based machine. So, as is common in the strategy when we're dealing with these things, is that we have a notepad. Actually, if I wasn't watching YouTube, I'd be like, I can see myself do that. And we draw the stack from the top down. We track this. Obviously, the recursion side of it makes the stack very big, so we really want to get the program down as small as possible when we're dealing with recursion. So that's why we limited down to factorial 2. And now we're going to debug in. So what we have is our little assembly program, which is here. I print that out at the moment using our little pretty printer. Turn args to remove 0, yeah. Args to move 1. Args to move 0. Okay. I might, thinking about it, I'm just trying to think where, we're looking at this code and it's still pretty readable, but it'd be really nice to say, cool 20. If we got to 20 and instead of 20 we had, well, if 20 says something like message function main, that would be pretty cool. There's 2 ways we could do that. We could actually insert an instruction called message, which is a no-op in interpreter, but just sort of strings messages in. We could also do things like print stack at various times, just putting them in instructions. I'm not sure how much benefit that is. Or the alternative is we start to have a debug bed of debug information, and we would know that when we hit line 20, which we're printing, it would say start of function name list, and then we could just print it in. I'm tempted to go with the debug information. I haven't quite done that yet because I'm not sure how much time I'm actually going to spend debugging the bytecode interpreter. Most of it's pretty simple. The most complicated thing is going to be getting this call stack frames working correctly. And we're nearly there, we just got to get it recursing, so get it to having multiple stack frames. I've also had a few ideas how to make this a little bit easier in terms of the interface. I might overlay a structure onto the memory that lets us easily access the frame pointer, the locals, and the parameters, the arguments sent in and then shift that frame pointer around. That requires a few other changes. We'd have to have a fixed size stack, because you can't do pushing back on the stack because you might cause allocation, which would cause the overlaid structure to point to freed memory. But I think eventually we're going to anyway do that, because we have to go fixed a frame stack. We can't have our stack allocating and moving itself once we start having pointers to things on the stack, because it would invalidate the pointers. A push operation from pushing an argument could invalidate every single pointer we got. So I'm just I've got some ideas on how to simplify this up. But for now, I'd rather get it working, then we can get back to writing a few more tests. I'm not quite sure where to go with it all. Those were ideas I had while I was cycling home tonight. Now where were we? We're happy with it compiling. Oh, let's have a look. Yep. Just get myself familiar with it. So, sub1 call function. Let's annotate this a little bit so we can see what's going on. Function main. Now, there we go. It's telling me here, for instance, I'm calling factorial offset 3. Function factorial return. Let's have a look at the program I'm actually running. I'm wondering where that's coming from. Hope this is reasonably clear. I love the way that. Right. Why is that? Oh, thinking 0, so that's fine. We've got no local variables. I'm going to get rid of that soon. The other alternative in debug, we could just attach a message to every single instruction. It could be things like allocate space, read local, read variable y, load member x, and so on. Load constant 5. Right, let's put that out of the way. We're happy with the first instruction. Into there. P0, ink instruction pointer to make the space of return value, call the functions that push the two things. We should be at IP20, yeah. Increment space for locals. Stack pointer. Interesting. Now what number are we at? IP is 21. That is ink stack by 1. Yep, that's the return address, the return value space. This would be a great example where if this was code we can get rid of, where people are optimising because you've two places we can clean the stack. Let's just add them together and do it once. Obviously, this one doesn't need to be generated, and we can know that and stop generating it. Later on, we've got a to-do in there to do that. Okay, so where were we? So we're making the space for the return statement. Should I grow this a little bit? Probably. There we go. Move on. Now we want to do x minus 1, so we'll load 1, push it onto the stack. We somehow got to call. What happened to this guy? Under sub. Did I miss it? Maybe I did. Let's run that again then. So I'm interested when we get to here. Right, IP is 22, which is load the value 2. Oh, of course we're still in main, aren't we? Then we call the function. Call the function, which is just changing our IP instruction pointer. Instruction pointer is now 3, which is cool. Ink the pointer stack, we have no variables. Read local, which is loading our x value. We should now go into load data. Now we look on our stack, we should have 1 and 2. So we're going to compare them because we're in the middle of the start of the if statement. Do equals. Can I see them on here? They're not equal, so we should push 0 on the stack. Let's go down and find the stack. Yes, we do. Now we jump 0, so if it's 0, we jump to read in the local again. But let's go to jump. We take it off because we've done the compare. You could argue that should be 2 things, but no, it has to come because the stack, if it's register, it could stay there, which is a reason for having the compare register, I guess, rather than using the stack. Compare equals 0. Yep, that's fine, so we're going to jump over the code. Now we should be reading the local again. I wonder what this should be. 24, so that's returning. Apparently, yep. That's our return value, so good, we've got nothing else on the stack. Push the local. And we've now got 2, we just read it. Read the x value. We should ink the stack pointer. Okay. I wonder why we're doing. That. Oh yes, we are. We're returning x by the factorial. That's good. Read local that. So we now should have 2. 8 is 0. Oh, it's because return. and then we should now read the value 1, load the value. Yep. Now we should go to sub, and we go up here, LHS is 2 minus 1, so we go down to 2. So we go down to 1. And let's have a look on there. So this is the parameter we're going to send into our next call. This is the space to the return value. So now we're going to put the stack pointer and stuff on there to store that off. We've got another 2, 10, 11. And now we should now go back to 3. IP is 3. A thing, we make some space for our local variables, which is not a thing. Then we read the local for comparison. For this time we should be having 1 on there. 1, yep. We load in the 1. Yep. And then we do an equals. It would help if you could see, so let's have a little look. We are currently at IP number 6, so we're just about to execute the equals instruction. I seriously doubt you really want to follow along. This time that should be 0. It should be 1. So let's check the bottom of the stack. We should have the number 1, which we do, 12. It's number 1. Yes, that's fine. Now this time, jump 0. This time it's not 0. So this time we're going to load 1 again. We've got duplicates on that. There we go. 9 is 1. 12 is our return. Yeah. We should move that into return. Okay, that's good. So what was our return? 8. Now contains 1. Now we should now do a full, next instruction should be return. Yes, removing 0 arguments. Alt FP. I'm really hoping I thought the instruction offset held the number of parameters. It's saying 0. I'm less than happy with that. Now if we head up here, have a look at return. Number of formal parameters apparently is 0. It should be 1, he says. And that's why none of them are working, because we 0. So let's have a look at the parent. Okay, it's okay, so my now question is, why have we got 3 tables on this? Let's have a little think by looking at our code. Tutorial is a function with a little bit of code like that. And coming into here, you would expect yes, you would expect one. Well, you're expecting this to be a new code block, which should be a new symbol table. Of course, inside a return. We are in here. My mouse is going very slow. Do I just alter the DPI on it? Better. We're in here, which means that we are not in this guy. So this guy's not been set. Number of arcs has not been set because it ain't interesting to it. Cool. Not a recursion problem. Should explain this a little bit better. This is our function. There is a symbol table here. We create a new symbol table here. Symbol table. And then finally we create a new symbol table here. This one, when we create it, we set this one equals 0 because we never set it. Okay. Now when we return, because return is inside this code block, its symbol table is this guy, so it's thinking it's got 0, which means we don't take the extra element off the stack and we get 1 times 1. How the hell that was working? Nah, some weird artifact. I'm wondering how it's working for the other cases, but I suspect it was just an off by 1 and every time it was, I don't know. So we understand the problem now, and then we've got to think of a way to fix it. The trouble is, there's no real way of I think we added, because I bought some more tea, because tea is awesome, particularly into the evenings, red bush or roobush or however you want to pronounce it. I think it was when my parents got me onto it many years ago. Alternative tea that's caffeine free and red, which is great. Made from twigs from Africa or something like that. No, I don't know how it's made. Yeah, it's caffeine free, it's like it, and I mean it's quite sweet at the moment, but if you ever go on a totally sugar-free diet, I mean really totally avoiding milk as well to avoid the lactose sugars in it. Which I did a few years back. Red bush tea goes really sweet. Suddenly your palate for sweetness goes really down, and so you can taste sweetness in things, and red bush tea just went this weird sweet flavour to it, which was nice at the time. I'm eating too much sugar at the moment, so I wouldn't know for sure. Don't get that flavour now. The tomatoes all smell really sweet. And you lose a lot of weight, which I could probably do with doing soon, as I signed up for a half marathon in October. Anyway, I'm meandering what I'm thinking, sorry. It's now I reckon if we look here, well actually we can look here, can't we? P to return value offsets. Can we use that? No, we cannot. Ooh, we could. Stack frame to return value offsets. If we take 3 off that, we've got the number. The alternative is in here we track the current function. So do we magic number or do we? My vote goes for current function actually. Current function symbol table. So to reiterate, our options are, we use the FP to return value offset, so that indirectly tells us the number of parameters because they come up before the return value, and we only have 3. We have to take off the return value, good stepping back, the instruction pointer continuation address, and the old frame pointer. So we know to take 3 off that, which would give us, well, -1, so we'd have to multiply it by 1. You know what? Let's do that because it's easy. First of all, used? I don't think it will be used once we're done. It's another one like that. In this case, no, not that. Info dot plus 3. And I know it's negative. Then we want to how can that fail? Let's find out. Well, I'm putting my thumbs up. I don't actually know it's true or not. There we go. The number of tests passed is cool. Now we go back to main. You're passing. passing. So this is all the different ways we write factorial. You're passing. You're passing. One of these got to fail. 5 test pass. Getting a sight in. 6 test pass. Anything else? Should this fail, so we leave that there for now. All 40 tests now pass. Cool. Do I want to write a non-recursive one? Do I have a while loop in here? No, I don't want to write a non-recursive one because it adds no value. There's no point adding a test that doesn't add value. Prove we can do that. We'll prove while loops work. Probably haven't proved not equals. Do we have a not equals? We probably do. Yes, we do not have a not equals. Lexa, not parser. Where are you? We do not have a not or not equals. It's probably a simple one. We could almost do that now, but not the goal. I've improved that somewhat. I'm going to take that out. Actually, turn up compiler warnings. We've still got to do. Oh, well, yes, she did some of that. We've got a nice set of. Where are we? Let's take those back out. Awesome. So we've got 41 tests, all passing, all looking good, and we have some other little program that's running. Right, well, what should we do now? Yes, commit that. Did that work? Yeah. Now it's going to want to do lots of complaining. Oh. How are we doing for time? 9:48. We're not even going very long, and my brain is slowing down. Okay. Well, let's go back to our plan. And mark compiler warnings. Did we do some of that? They are turned up. Could turn those up, but I think in lieu of saying, look at that. You're seriously telling me that that didn't. Did we save that? Okay, reloaded changes. Rebuild project. I'm suspicious because normally I turn on pedantic errors and it flies everything out. We'll leave that for now, but we might turn that down. Conversion, I know we've got some problems there, it's the longest sign conversion. But what we can do, which I don't want to tackle just yet, what we can do is, I'm very keen on the switch warning. What that does is, if you don't have a default, I'm pretty sure you should have a default on your switch statements, and you're using an enum, and you miss out some of the enums, it warns you saying you've missed out enum blah. So the assumption is that you're switching on an enum, therefore it's a closed set of items, you're switching on a closed type, therefore you should be handling them all. Put a default in handling them all, otherwise it expects you to have a case statement for every single enum. I like it. It now enables the compiler. It enables switch statements to act a lot like virtual functions. So virtual functions have the nice feature, other than they have the indirection and lots of other things. But the nice thing about them is that if you add one, all your inherited types, all the classes inherit from your base interface type, complain, saying, oh, we don't implement blah. So your compiler tells you where to go to implement these things, which is great. The minus switch gives you the same thing. If you add a new type to your enum, you get warnings about where to go, so you don't need to go searching for your switch statements, which is nice. I mean, you know, it is one of the things that it was sort of the final, not final, how do I say it? One of the things that really helped put me off a lot of RO programming, because one of the things was, well, I like types. I like a compiler leading me when I add one, leading me through where to put things, or you know, if I add an interface, the compiler tells me, so I know where to go for everything. Well, switch warning gives me the equivalent, just with simpler code. By simple, I mean all the things you want to think about at the same time are in the same place. The arguments against that, because sometimes all the things you want to think about are different, so they, you know, it depends how you cut your code and what problems you're solving. I'm certainly not strongly anti-C++ as many others. I find a lot of nice stuff in it, but I'm not solving the same problems as people solve, so I'm anti-slow compile times more than anything, and I would drop, certainly at home, I would drop almost any feature to get that. Any single feature is not worth long compile times. At work, it's compromising it. Big teams, big varying number of views. Anyway, there we go. I will say, there we go, we can put that in there, and that's an optional thing, just, I don't know. So, make sure everything builds, yeah. I'm going to go with a done on that. Went over functional rather than actually doing pretty well. I wasn't expecting to get through this. Obviously I'm putting off this guy, get error logging working. we're going to do it as a singleton. I think I spoke about this in the goals. I've been thinking about this a little bit more, and I think I may put off UTF-8 support until we get string literals. For me personally, as a personal project, I'm not worried about you making Unicode characters variable names. I know others are. My keyboard, I'm sure I can generate them on my keyboard, but for now I may delay that till we get string literals, which will force the issue because we have to do strings properly. How have we decided to do arrays or slices, or we just see a slice being a beginning and an end, or a size, start and a size, which bizarrely is going to be not quite sure yet. Ain't quite sure how we're going to define a slice. We're not even there, so let's not worry about that just yet. Do we go for fixing up? That would be a bit boring. I mean, it's useful to do, but if my body's twisted or oh, that's better. I think my DPI switch is great. Okay, we're really struggling. Let's have a little look at factor code. Hello, is the whole project? How big the project is. Plenty of spelling mistakes and plenty of warnings. General simplified statement, that's interesting. Condition is always false. Well, yeah, because we're... God. While I love clang tidy sometimes, I mean, really, inclusion of a C++. You see us at first. Well, okay, if you really want me to. Why can't you just change it for me? Thank you for, you know, doing that. Uninitialized record type V. Yeah. Because it's initialized here. It's a union. Wonderful. Might need to play a bit with. Come on, you kidding me? Oh yeah, improved. Massively improved. Oh yes, look at that. So improved there. Okay, let's see if we can get something else. Yes, that's a good one. Explicit, not that it matters that much because we're not taking anything that could be instant. No. Explicit, these are worth doing. Explicit means that we don't do any implicit casting. It has to match exactly. Important, you know, if you've got an integer and you don't want some other type to be cast to it, like a size t, or vice versa. Although vice versa may not happen without a warning. We do not initialize the fields. 12. Follow me down. You know what? I'm okay with that. But that should be a null pointer. We should always initialize our null pointers. Macro should be enclosed in parenthesis. What? Yeah, of course they should, because, you know, yes they should. I shouldn't complain. Yeah, they're probably going to complain about all these as well, but the expression is not redundant. Expression is very needed. Does not initialize these fields. Well, you know what? Do we have an invalid for that, or did we not bother with it? We did not bother with it, so we're clearing up a few. Empty should be, yeah. The changing change, let's run that through. Yep. CMake, version control, spectrum results. It's not complaining about the type. Parent? I can't even see the parent. Must be different structure. I mean, I know it's always initialized, so it's a bit, but I know always when I'm in trouble. I know people always say, you know, oh, wait for the compiler to tell you something's wrong. Condition's always false. I know we've got some sign mismatching going on in quite a few places. I've deliberately left them because what I want to do is, once we've got the code tidied up, have a little think on types, like the function offset should be an int 32, shouldn't it? But I guess it's not. No, not F12. Size T. You see, so that's because it's storing them in size T's. We'll always get some casting unless we make everything size T. We can't put that in. Maybe I should put it. Right. I want to mismatch values of type size T may not fit into receiver of type I. Yeah. So let's go into there. Int 32_t, which is then going to complain about this. So if we go into here, and then we make you int 32_t. Now, where are you set? Imagine it's you that I need to look at to find out where you're reading. Now, Yeah. Someone does something crazy, at least if I do something crazy, we end up with more than 2 billion tokens. Should be 2 billion 8 billion gigabyte would be 8 gigabytes of bytecode. Then which will take a while. Then me search won't you go? Take a while because search won't you been released, so you're only going to see this in debug. Now, how many did we say in total up here? 35 warnings. Let's see how that runs. Whoa, something happened. Warning. Ooh. What's your name? These ways does get fun. God. Bloody. And that was good. Well, so what I'm doing there is tidying up some of the types. I have a slight lisp, and I sometimes when I'm speaking hear it more than other times. Maybe I have a really bad lisp, I don't know. People aren't too polite. Just in case there's any chat. Now I've lost track of where I am. Okay, 40 tests and all is good. Let's run the inspect code again. Clanked IE. See if we produce that. Come on, you can do it. It's not going as many as before. Still plenty of typos, which I'm not going to do. I can't remember how many we had. Unused code warnings. No builder is never used. The whole thing? Really, should we use it? Ooh, I think I'm going to be summoned and... Yep. Okay, I think I'm going to call it a night, and I may carry on this a bit more actually off stream, but I think that's the end of a stream. Hopefully tomorrow we shall return and carry on building our little interpreter. Okay, thanks a lot. Bye.